How would you describe the inertial propulsion concept?
The inertial propulsion concept involves a unique propulsion system design. The core idea is to utilize a chassis shaped like a heart, with two hollow chambers that mirror each other. Within these chambers, projectiles are placed. These projectiles are simultaneously shot outwards in opposite directions through dedicated tubes, creating a contained force and pressure behind them. As the projectiles travel through the channels, they experience acceleration. Upon reaching the curved section of the heart-shaped structure, the force generated by the projectiles is distributed along the curve, resulting in a unified directional force. After traveling along the curve, the projectiles fall. Utilizing their velocity and energy, they are then fired again, initiating a repetitive cycle. To ensure stability and control, computer-controlled systems are implemented to stabilize the propulsion system and facilitate the reloading process. This concept is intended to harness the reactive forces generated by the projectile's ejection and subsequent movement to create a unified and directed propulsion force. The specific details of the design, such as the dimensions, materials, and mechanisms employed, would need to be further elaborated and analyzed to fully assess the feasibility and functionality of the concept.
I am asking you to help me build this idea, and I need you to describe to me the steps to take.
Certainly. Here are some general steps to consider when approaching the development of the inertial propulsion concept: conceptualization and design. Start by refining your concept and developing a detailed design plan. Consider the dimensions, materials, and mechanisms that will be involved. Determine the specific characteristics of the heart-shaped chassis, the chambers, tubes, and the projectiles. Decide on the overall size, weight, and operating parameters of the system. Analysis and calculations. Conduct engineering analysis and calculations to evaluate the forces, velocities, and energies involved in the system. This will help you determine the feasibility and performance of the concept. Consider aspects like the forces generated during projectile ejection, the acceleration along the channels, and the energy distribution along the curved section. Material selection. Choose appropriate materials for each component of the system based on their properties and requirements. Consider factors such as strength, durability, weight, and compatibility with the operating conditions. Materials like metals, aluminum, steel, composite materials, carbon fiber composites, and high-performance plastics could be considered. Prototyping and testing. Develop prototypes of the different components and assemble them to create a working model. This will allow you to evaluate the functionality, efficiency, and stability of the system. Conduct thorough testing to assess the propulsion force, projectile acceleration, and overall performance. Iterate and refine the design based on the test results. Control and stabilization systems. Integrate computer-controlled systems to stabilize the propulsion system and ensure precise control over the reloading process. Develop algorithms and control mechanisms that monitor and adjust the forces, timing, and positioning of the projectiles. This will help maintain stability and optimize the propulsion efficiency. Optimization and improvement. Continuously evaluate and refine the design to improve efficiency, reliability, and safety. Consider feedback from testing and explore opportunities for optimization, such as reducing friction, enhancing energy transfer, or minimizing recoil. Iterate and make necessary adjustments to enhance the overall performance of the system. Safety and regulatory compliance. Ensure that your design adheres to safety standards and regulations applicable to propulsion systems. Consider any legal or regulatory requirements that may impact the development, manufacturing, or usage of your system. Throughout the entire process, consult with experts in propulsion systems, materials science, and control systems. They can provide valuable guidance, assist with calculations and simulations, and offer insights based on their expertise. Remember that developing a functional propulsion system involves a complex integration of various engineering disciplines. It's important to approach the project with meticulous planning, attention to detail, and a willingness to iterate and improve based on testing and feedback.